Hello Year 10 and welcome to Sequences Lesson 3. Today we're going to be looking at arithmetic sequences from patterns, but we're going to start the lesson with the answers to yesterday's work where we were looking at finding the nth term of a decreasing arithmetic sequence. So the first example here, we're going down by 3 every time. So we know we're looking at the negative 3 times table, so negative 3n. And then we're adding 10 to that, so 10 subtract 3n. The next one we're going down by 10 every time, so we know it's going to be negative 10n, and then we're adding 25 to that. And then for the next one we're going down by 2 every time, so negative 2n, and then we're adding 8 to that. Then we're going down by 5, so negative 5n, and then we're adding 14. And then we're going down by 9, so negative 9n, and then we're adding 21. So those were the ones which you really ought to be able to do. And these ones were just perhaps slightly more tricky. The first one, again, because we're dealing with negative numbers from the beginning. So we're doing exactly the same thing. We can see that we're subtracting 11 each time. So we're going to compare to the negative 11 times table. And then each term is 1 more than the negative 11 times table. So negative 11n add 1, or 1 subtract 11n. So the next one is decimals, and we can see that we're subtracting 0.4 every time. So negative 4n, and then we're adding 1.1. So 1.1 subtract 0.4n. And then we've got fractions again. So hopefully you can see that if you just concentrate on the denominator, we're dealing with quarters, and each time we're subtracting 3. So we're subtracting 3/4 every time. So we want to compare to the negative 3/4 times table, and then we're subtracting 6/4 away. Okay, so today's lesson, arithmetic sequences when they're given as a pattern, and we're going to do this by looking at some exam questions, and then I have 4 exam questions that I want you to try. So we have been given a pattern that's made from sticks. This is still labelled number 1, number 2, number 3, so this is like the term number. And then to find the actual term itself, I need to count the matchsticks. So for example, this one here has got 4. So term number 1 would be 4. And this one's got 7. So term number 2 would be 7, and so on. So the first question is, draw pattern number 4 in the space below. So I need to think about how this pattern is changing from one pattern to the next. And hopefully you can see that I've got these 3 here, which are being added every time. So pattern number 2, I've got 2 of those 3 matchsticks, and pattern number 3, I've got 1, 2, 3 of those 3 matchsticks. So pattern number 4, I'm going to have 4 of them, and then I'm going to have the extra one on the left-hand side. So essentially it's going to be pattern number 3 with an extra 3 added on. Okay, so it's going to look like that. So next question, how many sticks are needed for pattern number 12? So you could just keep drawing patterns until you got to pattern number 12, and that would get you the right answer, and it would also get you the marks. But the problem is you would be there for a long time, and that would cost you a lot of marks that you should otherwise have had a chance to answer. So we need a better way to do that, and there are a couple of ways. So first of all, you might decide to write down the terms themselves. So as we said, this has got 4 matchsticks, so that's 4, 7, so the term is 7, and then 10, so the term is 10. And then we can do what we were doing in the last couple of lessons and look at the common difference. So we can see we're adding 3 every time, so we know this is going to be a sequence involving 3n, but it's 1 more than the 3 times table. So we must have an nth term of 3n plus 1. So if I want to work out pattern number 12, well, that's going to be 3 lots of 12 add 1. And if I use BIDMAS, 3 lots of 12 is 36, and then I'm going to add 1, and that gives me 37. There's another way of finding the nth term when you've got the pattern though, and that is that you can see pattern number 1 has got 1 lot of 3 plus an extra 1. Pattern number 2 has got 2 lots of 3 plus an extra 1, and pattern number 3 has got 3 lots of 3 plus an extra 1. So pattern number 12 must have 12 lots of 3 plus an extra 1. So you don't actually have to work out the algebra here. You can do it by analysing the pattern. Okay, next part of the question. Sunil says that he will need 76 for pattern number 20. Is he correct? You must give a reason for your answer. Now, the reason here does not need to be a paragraph of writing justifying what's going on. The maths is sufficient. So it makes sense to me to say that if I now know that it's 3n add 1, well, I can try pattern 20. It's going to be 3 lots of 20 add 1, which will give me 60 add 1. And so I actually only need 61 matchsticks for pattern number 20. So he must be wrong. There's an alternative though, slightly trickier I think, and that's to use the 70 sticks and work backwards. So if he has 70 sticks and we take off this one extra one, he'll have 69, and it's always 3 times the pattern number that's being made by multiplying these 3 matchsticks by the pattern number. So I need to work backwards and divide this by 3, and that gives me 23. So I can either say pattern number 20 needs 61 matchsticks, not 70, so he's wrong. Or 70 sticks makes the 23rd pattern number, not the 20th, so he's wrong. Okay, here's another example. We have got another type of pattern here. This is slightly different because we've got 2 different sequences going on at the same time. We've got the grey squares, and then we've got the white squares. Or we can see it as the total number of squares altogether. So there are actually 3 different sequences. So in the space below, complete pattern number 4. So if I look at what's being added from pattern 1 to pattern 2, it's this bit that's added, these 3, because this white bit is already here. So I add another 2 greys and a white. And if I look at how I change from pattern 2 to pattern 3, again, it's these 3. So what they've drawn down here is pattern 3, and I've got to work out what I need to add to this to make pattern 4. So I'm going to take these 3 and I'm going to add those on. But the 2 in the top and the bottom need to be grey. And so that's my pattern number 4. Right, part B says find the number of grey squares in pattern number 6. So again, a couple of ways of doing this. Number 1 is to actually write out in numbers the sequence of grey squares. So pattern 1 we've got 2, pattern 2 we've got 4, pattern 3 we've got 6, and then pattern 4 down here we've got 8. And that is the 2 times table. And we know that the nth term for that is 2n. And therefore the 6th pattern will be 2 times 6, which gives me 12. The other way is to analyse the pattern itself and say, well, pattern number 1, I've got 2 lots of 1. Pattern number 2, I've got 2 lots of 2. Pattern number 3, I've got 3 lots of 3. Pattern number 4, 2 lots of 3 rather. Pattern number 4, I've got 2 lots of 4. So pattern number 6, I'll have 2 lots of 6. Right, part C, a pattern has 12 grey squares. Work out how many white squares there are in this pattern. Now, I think it's far easier to do this by analysing the pattern. If we just forget about the extra white tile that's being added every time here and here, we can see that we've got double the number of greys than whites, excluding this extra bit. So I can work out how many whites I've got in between here, excluding this extra bit, by halving the 20 grey squares. So I must have 10 whites sandwiched between the grey tiles, but then I have got the extra one always sticking out on the end. So I need to add one on, and that tells me there are 11 white squares. Okay, so there are 4 exam questions which I would like you to have a go at. You're going to need to pause the video to answer these into your maths books. I will upload it and attach it to the assignment as a PDF file as well, so that if you want to and you have access to a printer, you can print it out. But otherwise, you don't need to print it out. You can do it from the screen. So pause the video to answer these 2 and then press play again to answer the next 2.